Hello, Professor. My name is Yahya Rodriguez. My lab partner is Carlos Brazosca, and today I'll be presenting the Lab 6 stepper motor. So the purpose of this lab is to connect the stepper motor to our TM4C launchpad and then power it. So as you can see here, I have two include statements right here. I have include st.int, which is essentially going to provide some data types for several of our values in the lab, and then the include statement of TM4C123, which essentially what's going to do is provide some data or information for several of our defined ports in the lab. Some of these could include defined ports for our GPIO ports. Furthermore, we have several functions that we must go over. The first three being disable interrupts, enable interrupts, and wait for interrupt. Essentially what these do is obviously do what they do. We've been using this for the previous labs. Disable interrupts, enable interrupts, and the wait for interrupts essentially continues until it waits for something to occur. In this instance, it'll be an interrupt, and then based on the interrupt, it'll do something. Then we have switch init, which is going to initialize switch 2 and switch 4, which in this case is PF0 and PF4. Then we have the switch handler, which is essentially going to generate the interrupts for port F, and it's going to, based on those interrupts, it's going to do something to the DC motor. It's either going to rotate it to counterclockwise or clockwise based on the switch input. Then we have the GPIO port B LED init, which is going to basically use the port B to initialize the LEDs for the driver. Then we have systic wait and systic wait 500 millisecond ms, which is essentially going to create the 0.5 second delay for our lab. You should keep in mind here that we have int I, which is going to be used later on to help with the rotations for the DC motor. Then we have several defined statements. We have some for port B, port F, as well as we have the system clock turned on here. And we also have some defined statements for the priority and interrupts for the lab. So before going to the main, we'll first go to the switch init. So the switch init is where we initialize PF0 and PF4 and PF0, which is both switch 1 and switch 2. Essentially, as you can see here, you should also keep in mind that we have the priority set to 2 for this, and we enable interrupt on 30 because that is the interrupt that controls everything regarding the GPIO port F. So you should keep that in mind. Also, we have the switch handler, which in this function is basically going to generate the edge interrupts for port F. So as you can see here, whenever switch 2 is pressed, in this case, that would be PF0, then it'll rotate clockwise, 90 degrees clockwise. As you can see here, we're using the wave drive method. So we have the GPIO port B data R. We have these several values, and then it'll cause a wait of 0.5 seconds to occur, and then it'll go to the next value, and then the delay, then the next value, then the delay, next value, and then the delay. And this repeats it for 32 steps because that's the amount of time it needs to create a 90-degree angle. And then it also analogies the flag here to make sure that it's able to do it later on. Then we also have it for switch 1. So whenever switch 1 is pressed, it'll go through the opposite method, and instead of doing it for 32 increments, it'll do 63, which is essentially 180. So instead of going clockwise, it'll go counterclockwise. And once again, we have the data set here, and we have the 0.5 second delay, data, 0.5 second delay, and so on and so forth. And also make sure to acknowledge the flags so that it could be used later on. Then we have initialize our port B LEDs. So as you see here, we make sure to initialize port PB3 to PB0. This is essentially going to control the LEDs for the specific states. So like A, B, C, and D, which we're going to use in the lab. We also make sure to set the system clock for port B, not F. So as you can see here, we have it set to do for port B. Then we have our systic wait and our systic wait 500 milliseconds. So essentially the systic wait is essentially going to provide some information for the systic wait 500 milliseconds. So as you can see here, we have several for statements. And then depending on the value of the delay, which is what we're going to import the lab, it'll essentially create a delay for that amount of time. So if it was 1, then it'll create a delay for 500 milliseconds. As you can see here, we have systic wait. And that value, we're using that value because depending on the megahertz of the clock, in this case, we're going to assume that it's 80 megahertz. It's essentially going to create, or it's going to wait for a specific amount of time. In this instance, it'll be 500. So all of these methods are going to be used to create a 0.5 second delay. And that would be the lab. So let's go back to the main once again. So once again, we have our disable interrupts. So it's going to disable all the interrupts while initializing. Then it's going to switch init, then switch handler, then the GPIO port VLED init, and then finally, the enable interrupts. So now once that's all through and done, we'll be able to finally do the lab. So we're going to save it, then build it, and then load it. And then we're able to see what we're trying to do right here. So we load it, and if you could see right here, we have all our LEDs turned on. However, it doesn't, no matter how hard I try, it doesn't seem to like do anything. It always seems to stay at the state for 1111 for A, B, C, and D, even though I'm clearly pushing the switches. So I'm really not sure how I'm able to get this to work. I tried to do it without the edge interrupts, just try to like get it to rotate by itself, but it still won't be able to do it. So I'm kind of confused on that. Unfortunately, this was always able to come up a bit, so I'm sorry about that. So I thank you for letting me present this lab. Thank you, Professor, and I hope you have a wonderful day.